Okay, today, organizing coordinate proofs, there's a few things we need in order to be able to do coordinate proofs. One is to be able to find different points on a coordinate plane based upon not necessarily numeric links, but links given in a variable format. Okay, we're going to also be using these three formulas, so we need to have these three formulas down. Okay, so the midpoint formula. Tell your neighbor what the midpoint formula is. Yes. Give you a hint. Taking the average of 2 points. What is this? X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. Okay? That is our midpoint formula. It's a coordinate of the midpoint. Slope formula. I guess maybe rather than calling this M, we may want to call it midpoint since we call slope M. Okay? Or mid. Okay? The slope M is equal to, anyone remember? That is a slope-intercept form. That is slope-intercept form. Rise over run. Maddie? Boy, I had two Maddies. We have y minus y over x minus x. I should have been more specific with the Maddie I called. All right, it's the difference in your y values over the difference in your x values. Okay, so we rise over run. Distance formula, D equals all right. There, got it. Got our three formulas. This does not apply to this textbook. However, it does apply to the worksheet I gave you. So we'll go through that sheet together. Okay? So that is y2 minus y1. Let me kind of zoom in there. You have your distance, your slope, and your midpoint formulas. Okay. Very good? No. Uh-oh. Let's try some of these. Take a look at this sheet. This is the one you picked up on the way in. I want you to be on this side of it as the 1, 2, 3, and then 7, 8, 9. Find the coordinates of W and Z without using any new variables. All right. So, let's go ahead and start with number 1. I want you to find the coordinates of W and Z. Give it a go, please. Okay, let's check it out. So, W, any ideas? Maddie? Yes, Jacobson? 0H. So, how did you get the 0? Good, x equals 0 right here, so you follow that up. That is 0 on the x-axis. And how did you get h on y? Good. It has the same coordinate as this point. Very well done. Okay. So this is h right there. Nice work. Okay. Z. Anyone? Yeah. B on the y-axis. Same coordinate there. And 0. B on the x-axis and 0 on the y-axis. B0. All right. Any questions? Okay. Everyone try number 2 and number 3. Give those both a go, please. Okay, volunteer for W. Maddie Anderson. You got what? ZA. I will go with not ZA. We can't use this point because that's a coordinate. That's a vertice that we're trying to find. True? Could we use B? We can't use a new variable. Danica. How do you know it's AA? Good. Keyword there is a square. If it goes up that far, that means this length is A, which means this length is A. So A is that coordinate, which makes this length A0, or that coordinate A0. Okay? Good job. Bless you. Yeah, Jeremiah. Negative B, B, and negative B, negative B. Good. All right. Very good. Any questions? Okay, what I want you to do now is the bottom three. Okay? Just find the coordinates of the midpoint of WZ and then find WZ. This means find the length of WZ. Okay, so the midpoint and then the length of WZ in exercise 1, exercise 2, and exercise 3. Okay? Off you go. You work together, do your bestest. Okay, let me get you going. Checking number 7 here. Midpoint. Midpoint of WZ. So we're going from here to there. Okay, it's not a line we actually see, right? So for those of you who are like, man, that's an ugly line. There we go. Okay, that's not any better, but you're going from here to there. Okay? So we have O and BO. Alright, so the midpoint would be our x1 plus x2 divided by 2, and our y1 plus y2 divided by 2. So in this case, if we're dealing with that, we got our x1 and our x2. Okay, we end up with 0, if we call this x1, and this one x2. We got 0 plus b over 2, or just b over 2. And if we call this one x1, we have to call that one y1 and y2, and in this case it really wouldn't matter. You end up with h plus 0 over 2, or h over 2. So your ordered pair, b over 2, comma h over 2. Somebody got it? Okay. Somebody else? All right, let's try the distance for that one. Distance formula. So d equals square root of x1, or x2 minus x1, squared, plus y2 minus y1 squared. So in this case, when you have a 0 in there, so you have your b plus 0 squared, and your 0 plus h squared. So in this case, it is d equals b squared plus h squared. Oops, h squared. Square root of that. Now, can I just take the square root of each of those? KJ, question? In the parentheses. Oh, yeah, this should be, thank you. That should be minus. That should be minus. Good call. It won't change it, but thank you for pointing that out. Hey, can I just take the square root of both these? Call it good? Yeah? Yeah, you got to add them together first, right? Okay, so for those of you who are like, yeah, I just took the square root and just called it b plus h. Remember, that doesn't work. I mean, if you had like the square root of 9 plus 16, okay, well, square root of 9 is 3. Square root of 16 is 4. So if you just said that, hey, that's equal to 7. Okay, well, what is 9 plus 16? 25. What's the square root of 25? 5. Okay? So those two things don't gel. Okay? You can't do that. Okay? You have to add them up first. Okay? Any questions there? All right. Hey, guys, number 8, you should have got A. So your midpoint would have been A and A over 2. Your distance would have been A. Yeah, Jeremiah. Or, excuse me, Alex.
So would the distance for number 7 just be square root B squared plus A squared? Would that be the answer?
The distance for number 7?
Yeah, would that be the answer?
Yeah.
Oh.
Yep. That's the distance. That's the distance for number 7, yeah. Okay, number 9. Midpoint is negative B, 0, and distance is 2B. Okay. I'm just seeing how long before he tips over. Eventually he'll fall out of his seat.
Oh, that's 11.
No, we won't do that. Okay, take a look at the back side of this. Hey, I don't want to do all these, but I want to try number 4. Okay? So, once again, give the coordinates, W, Z, without using any new variables. I want to do number 4. That's kind of a tougher one, and then we'll do number 10 and call it good there with these. Talk with your neighbors, W and Z. Hey, let's go with W first. What's W? 0B. All right. Hey, Z's a little tougher. Brennan? What'd you say it was? A minus C, 0. Not A minus C, 0. Good thinking, though. KJ, what do you got? Is it A0? It is A0. Okay. KJ, how'd you get that? I think we know how you got the 0 for Y, but how'd you get A? Straighten it out. Okay. Oh, sorry. Oh, okay. So out here. Yes? Oh, over here? Over here? Okay, so you straightened it out like that. Okay. Can I help out? You guys, if this entire length from here to here is C, and to get back to this point, you have to take away that much. That's the amount you're moving right here. These two distances are the same. Okay, so this is A. You're going from C to C minus A. That means this length is A, which means that length is A. Yeah. It is. It's a parallelogram. In a parallelogram, opposite angles are congruent. Yes. All right. Hey, find the coordinates of the the midpoint and the distance there. WZ. I'm not going to go through that. I think you guys have it, at least in terms of calculating distance and midpoint. But if you want those, that would be A over 2, comma B over 2, and your distance would be the square root of A squared plus B squared. Okay, so if you calculated those, there they are. I do have one other piece I need you to do while I'm handing out your assignment today, and here it is. I want you to calculate the slope of each segment listed there. Find the slope of each segment listed. Hey, what's the slope of pi? Yes. Good. The slope of pi is 0. It's a flat line. Shouldn't have to do much calculation there. It's 0. Okay. What is the slope of ik? And first, is that a positive or negative? Positive. It's rising from left to right. Slope formula. y2 minus y1 over x2 minus x1. If I call this one x1, y1, and this x2, y2, hopefully that's pretty easy, right? You're subtracting 0. So both of these parts become 0, and you're left with a over 3b. Okay. Wait, what? Yeah, it's still a positive slope. You look at the line from left to right.
But isn't your starting point I?
No, it doesn't. You're naming this line, so it doesn't matter which order the variables are in. This line's going up from left to right. It's a positive slope. How about KE? It's also 0. Okay? And P to E, we have positive or negative? Positive. Okay, so once again, if we're dealing with this and we call this x1, y1, x2, y2, we have 0 minus b on the bottom there. 0 minus negative b. And then we have a minus 0. So our answer is a over b.